Morning, I am Jessie Pies. I would like to explain about scanning tunneling microscope. So, a microscope is a device which is used to view smaller objects which cannot seen through naked eye. Scanning tunneling microscope is the highest resolution imaging and nano fabrication technique available. It depends on the quantum tunneling of electrons from sharp metal tip to the conducting surface. Principle: the basic principle used in STM is tunneling of electrons between the sharp metallic tip of the probe and the surface of the sample. STM has a metal needle that scans a sample by moving back and forth, gathering information about the curvatures of the surface. It follows the smallest changes in the contours of the sample. The needle does not touch the sample, however, it stays about a width of 2 atoms above the surface. Instrumentation: the STM is shown in the diagram and it is the following components: piezoelectric tube with a tip and an electrode. It's capable of moving in XYZ direction, fine needle tip for scanning the sample, and a macro scale image of the etched tungsten tip. The tip is affixed to the piezoelectric tube in order to control its position and movement on an atomic scale. Piezoelectric materials exhibit an elongation and contraction along their lengths when the electric field is applied. Working: the tip is mechanically connected to the scanner and XYZ positioning device. The sharp metal needle is brought close to the surface which is to be imaged. The distance is of order of few angstrongs. A bias voltage is applied between the sample and the tip. When the needle is at a potential with respect to the surface, electron can tunnel through the gap and set up a small tunneling current in the needle. This feeble tunneling current is amplified and measured. With the help of the tunneling current, the feedback electronics keeps the distance between the tip and the sample constant. The sensitivity of STM is so large, the electronic configuration of the surface atoms and the electron distributed around them can be detected. Applications: it shows the positions of the atoms preciously. It gives a three-dimensional profile of the surface. It is used to study the structure, growth, morphology, electronic structures, thin films, and nanostructures. And the resolution of zero point 0.1 nanometer to 0.01 nanometer in depth can be achieved. Thank you.